simplify the expressions above. I may need an additional piece of paper to show my work here. 1 second. Let's look at number 1. I know that I cannot take the square root of a negative. The negative comes out front. And I can see that the square root of 9 is 3. So I have 3i plus 2. Now let's write it in the form of a plus bi. So in the form of a plus bi, for number 1, I'd have 2 plus 3i. And this would be the expression after simplifying it. I'm just going to go straight across for the purpose of moving this. Alright, again, I can't take the square root of a negative, so it comes out front, and it comes out front as an I. Now 20 breaks down to the square root of 4 and the square root of 5. So I have 2i squared root of 5 plus 1i squared root of 5. These are exactly the same. Think of this as like a 2x plus 1x. 2x plus 1x would be 3x. Well, really, what is an x? It's I squared root of 5. Let's look at number 11. Okay, adding two quantities together that are complex numbers. I'm going to write them just as I see it here. Okay, like terms, the real portions. The real portions will have a negative 3, and now positive 2 square roots of 3i, and positive 5 square roots of 3i would give you positive 7 square roots of 3i. Now, by the way, any complex number, this is the imaginary portion, and here would be the real portion. Alright, let's take a look now at number 2, 7, and 12. So I cannot take the square root of a negative, it comes out front, and the square root of 4 is simply 2. So writing this in the form a plus bi, this is the real portion, and here's the imaginary portion of the complex number. This says take this quantity, and let's write it down twice. So the base is multiplied by itself twice. Again, you can't take the square root of a negative. I times I is I squared, and then I times the square root of 3 and the square root of 3. The square root of 3 times the square root of 3 is the square root of 9. I know I squared is equivalent to negative 1. So I have negative 3 for number 7. Let's look at number 12. I'm subtracting. Remember that when you subtract this, you must go to the 5 and to the I. So negative 5 and positive I. A negative times a negative is a positive. The real portion is negative 2. The imaginary portion is negative 1. Let's look at the next one. Let's take a look at 3, 8, and 13. You cannot take the square root of a negative. The I comes out front. Now the square root of 6 cannot be broken down, so let's just write it in the form a plus bi. This is the real portion, and here's the imaginary portion. Okay, let's look at number 8. Number 8. I take the negative out front, it becomes I. And I know that I can break I to the third into I squared, now with additional I. The square root of 16 is 4, so 4i. I squared is negative 1, and I have a remainder of I. I continue to simplify here. Positive 5i, and I can combine to give us 9i. Whether you write it like this or 0 plus 9i in the form a plus bi, either one would be correct. Now number 13, I'm multiplying. I'm finding the product of these two. So I'm going to come and make this box, and it doesn't matter if 4 plus 2i goes on top or down the side. Okay, I'm going to multiply to get 12, negative 8i, 6i, and negative 4i squared. Now I know that I squared is negative 1, so negative 4 times negative 1 is a positive 4. Alright, let's combine the terms here. 12 and 4 is 16, and 6 and negative 8 is negative 2i. Let's look at the next set of 3. Okay, let's look at 4, 9, and 14. Okay, so I have 2i plus 3. Now I know I squared is the same as negative 1. 2i, 3 times negative 1 is negative 3. And now let's write it in the correct form. The real portion followed by the imaginary portion. Let's take a look at number 9. This I comes out front, and I have the square root of 9 times I comes out front times the square root of 4. This is 3i times 2i, 6i squared, and we know I squared is equivalent to negative 1. Alright, let's take a look at number 14. Now, so for number 14, we need a multiplier multiply by the conjugate of the denominator. What does that mean? It means we write down the denominator, but what we're going to do is we're going to change the sign of the middle. So instead of it being positive, it will be negative. We're always going to multiply by the conjugate of the denominator. In doing so, our goal is to rewrite this in the form a plus bi and to have no i's in the denominator. Okay, so these are the two I'm going to multiply. I'm going to come off to the side, making my box. So I have 2i and 3 minus I. Okay, here we go. 6, 3i, negative 2i, and negative I squared. Well, negative times negative 1 would equal a positive 1. So when I multiply these, I end up with 6 plus 1 is 7 plus 1i. That's in the numerator. Now let's look at the denominator. I'm going to do the same thing for the denominator. I have 3i and 3 minus I. Multiplying, they give us 9, 3i, negative 3i, and negative I squared. So I have negative, negative 1. There's a negative, and I squared is negative 1. That gives me a positive 1. 9 plus 1 is 10. And these are additive inverses. They cancel out. So I have 7 over 10 plus 1 over 10i. So I'm still in the form a plus bi. I no longer have an I in the bottom, but I accomplish it by multiplying by the conjugate of the denominator. Alright, let's look at 5, 10, and 15. I squared is equivalent to negative 1. I can't take the square root of a negative, so the I comes out front. Negative 5 minus 3i, and it's already in the form a plus bi. No, plus bi, this is the same as plus bi, right? So negative 5, if you wanted to write it like this, you can, but I know a positive and a negative is the same thing as a negative. Over here, what does this mean? Well, I'm going to choose, I could write this out if this is what you prefer. You could write this out a total of 5 times, but I'm going to show you what I would do. I'm sorry. Instead of doing that, I'm just going to simplify first of all. So this simplifies to this. And I'm going to continue to simplify it. Okay, so this is negative 2 squared root of 2 to the 5th. Okay, now the next thing I'm going to do is this needs to be distributed to the negative 2 and to the square root of 2. So negative 2 to the 5th and square root of 2 to the 5th. Well, negative 2 to the 5th would be negative 2 times negative 2 5 times. And I have an odd number of negatives. So it's going to give me a negative answer, and 2 to the 5th is 32. This produces negative 32. I'll do the same thing here. Negative 2, negative 2, negative 2. Sorry, square root of 2, square root of 2, square root of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And the square root of 32 can be broken down to the square root of 16 times the square root of 2, which is 4 square root of 2. So this is times 4 square root of 2. 4 times 32, I gotta come off to the side and do the math. Negative 128 square root of 2. Let's look at number 15. So just like number 14, we need to find a way to rewrite this so that we no longer have an I in the denominator. So I'm going to take this times I. As long as I multiply the top and the bottom by the exact same thing, then I didn't change the original expression. So I have 3i on top. On the bottom I have negative 1 times I squared. And I know that I squared is the same as negative 1, so I have 3